A very important problem for coding down for the IT job aspirants, which says how many minimum number of jumps required to reach the end of an array, given the number of at most jumps one can make from an index position of the array. That means, taking that example, array A, we have 5 locations. You need to reach from starting location, that means from 0 to the end location, that is at 4, by taking minimum number of jumps, where each cell tells you how many at most number of jumps you can make from that particular index. That means, in this example, you see at location 0, we see that 2 is the number of jumps you can make maximum from that index. That means either you can go 1 at 1 index or you can go at 2 index. Similarly, at index 1, the value is 3. That means you can make 3 jumps at a time maximum. That means if you want, you can go to next location or at index 3, or you can reach at index 4. Now your objective is to find the minimum number of jumps required starting from 0 to reach 4. So if you consider the greedy technique, which always tells that you take that step which is most lucrative at a particular point of time. For example, if we consider greedy technique and we start from location 0, here we can make at most 2 jumps. So you are tempted to take 2 jumps so that you can quickly reach the last location. So you are taking 2 jumps and you are reaching at index 1, index 2. From here you can make at most 1 jump. So you can reach at index 3, from where you can reach the index 4. So how many jumps you are taking? 1 plus 1 plus 1, total 3. But is it the optimum solution you can make? No. Now you see, in a very simple way, if we start from 0, but instead of making 2 jumps, if we take at 1 jump just, because you can take less than the optimal number of jumps you can make from a particular index. So if you go just at index 1, from where you can make maximum 3 jumps at a time, so you can reach the location 4 simply jumping from index 1. So how many jumps you are making? 1 plus 1, 2. So it is the optimum solution what the greedy technique fails to give. Not that only, sometimes it may happen that greedy technique, though there is a solution, but greedy technique may not give you the solution. Like this example, if we start here, the example is having 2, 3, 0, 2, 2 as the number of maximum jumps you can take from that particular index locations. Again, you have to start from 0 and reach at location 5. So starting from 0 in greedy technique, as it is giving you the option to make 2 jumps at a time, you are tempted to take that option and you are reaching at index 2. But here you see that example tells that you can make maximum 0 jump. So you cannot take any jump. You cannot reach the last location. You are stand still here. So it is not giving you the solution. But does not this problem have any solution? It has a solution. Now you see, if we simply consider that we are starting from location 0, obviously you always have to start from location 0, but instead of taking 2 jumps, we are just taking 1 jump and reaching at index 1, from where we can take 3 jumps at a time and reach the desired location, location 4. So how many jumps you are taking? Only 2 jumps. And not only that, you are having a solution. So greedy technique doesn't give the solution always, and even if it gives you the solution, it may not give you the optimum solution. Now, what should be the right way to have the solution for this kind of problem? Again, as we always discuss, that can we implement dynamic programming here? Can we implement dynamic technique? when is we can implement dynamic technique? As I always say, that we need to check whether the solving any sub problem can help you to solve the next problem, then that problem is a candidate of dynamic programming. That means if a previous calculation can help you to get the next calculation, then it is a candidate of dynamic programming. So now just take an example and try to implement it. That means, say, here is an example. An array A is having 8 locations. Your objective is to start from 0 and reach at index location 7 by taking minimum number of jumps, where each of this index is telling you how many jumps you can take, at most number of jumps you can take from each of these locations. Our objective is to make solution for every index and use that solution to have solution for the next index. And by this way, we'll reach the last location. So we are taking a solution array B, where you will put the solution for each of this index, each of the steps we are taking. But for the first location, as you don't need any jump to reach at the first location, so the value of 0 location will be 0. That means we would initialize in our program B0 equals to 0. Now consider the second location, that means index 1. You see, to reach index 1, how many jumps you require starting from 0? So you see, to reach at index 1, starting from 0, you require 1 jump. And do your index 0 is having that number of jumps so that you can reach from 0 to 1? Yes, it is having 2. So you can make at most 2 jumps, and you require only 1 jump to reach at 1 from 0. So it is possible. So here you have solution 0 at index 0. You add 1 because you require 1 jump to reach from 0 to 1. So 0 plus 1 gives you 1. So from 0 to 1, you need 1 jump to reach here. Now you take index 2. So you can understand one loop will run. I am mixing the logic with the algorithm. So one loop, say starting from 0, I is equal to 0, and it will go up to the last location where you have to reach. That means I is equal to 7. Step by step. Now I is at index 2. You need to reach at index 2 starting from 0. Can you reach directly from 0 to 2? So what number of jumps you require to reach directly from 0 to 2? So 2 minus 0. 2 jumps you require to reach at 2 starting from 0. So can you do this? Yes, because 0 says that A0 says you can make 2 jumps directly. So you can reach at index 2 starting from 0 directly by having a single jump. So how many jumps you require? The value is here 0, and you require 1 jump to reach here. So 1. Now I plus plus. I comes at location 3. You need to reach at 3. You need to start from 0. Keep on trying. If you can reach 3 from 0, it is the best solution you can have. So how many jumps you require to reach at 3 starting from 0? You require 3 jumps. Can you make it? No, because at location 0, you see, you can take maximum 2 jumps. So it is not possible. So you cannot directly jump from 0 to 3. So you can have to try for the next index, that is index 1. At index 1, if you start from index 1 and reach 3, so how many jumps you require? 3 minus 1. You require 2 jumps. And your A1 tells that you can make 3 jumps. So it is possible to reach 3 starting from 1. So here your solution is telling that to reach at one location, index 1, starting from 0, you require 1 jump, and from there you can directly make a jump 1 to 3 by having a single jump. So 1 to 3 gives you here, so the solution is gives 1, and you require one jump to reach 3 from 1. So 1 plus 1 is 2. Now you go to I is equal to 4. You need to reach at 4. You start trying from 0. So how many jumps you require to reach at 4 from 0? 4 minus 0, you require 4 jumps. You can see it is not possible because it is showing you only 2 jumps you can make from index 0. So you go to the next index, that is I1. You can make 3 jumps here, and to reach at 4 starting from 1 you require 3 jumps. So it is possible to reach 4 location from 1 by making a single jump. And the solution, the pre-calculation made for index 1 is 1. So 1 to 4 you require 1 jump to reach from 0 to 1, that is 1, and another jump to reach 4 from 1, that is 1. So 1 plus 1 is 2. So you require 2 jumps to reach at 4 starting from 1. I'm sorry, starting from 0. So it is 0 to 1, it is 0 to 1, and then 1 to 4. Only 2 jumps you require. Similarly, if you take index 5, so how many jumps you require? 5 minus 0. 5 jumps. It is not possible to start from 0. So you go to 1. So 5 minus 1, how many jumps you require? You require 4 jumps. But it is showing you 3 jumps you can make at a time. So it is not possible. So you try for index 2. How many jumps you require? 3. But it is telling that you can make only 1 jump from 2. So it is not possible to reach 5 from 2. So you try for the next index, that is 5 minus 3. How many jumps you require? 2. Yes. See, at index 3, you can make at most 2 jumps. So you can reach 5 from 3 by making a single jump, because you can make at most 2 jumps. You can go 2 steps. So what is the solution at index 3? You have a solution at index 3 is 2. So you require 2 jumps to reach from 0 to 3, that is 2. And adding this, a single jump to reach from 3 to 5, you know that 2 plus 1 is 3. So to reach 5 from 0, you require 2 jumps only, 3 jumps only. I'm sorry, 3 jumps only. You see how you are reaching? How you are reaching? From 0, you are going to 3, and from 3, you are going to 5. So from 0, not you are just directly going to 3. From 0, you are going to 1. So from 0, you are going to 1, and from 1, you are going to 3, and from 3, you are going to 5. And that is the optimal solution you are getting for index location 5. That is 3, only 3 jumps. 1, 2, and 3. Similarly, if you take your I to 6, so how many jumps you require? Starting from 0, 6 jumps. Not possible, you can see very directly. 6 minus 1, not possible. 6 minus 2, not possible, because from index 2, you can make only 1 jump, and you require 4 jumps. It is not possible. So 6 minus 3, 3. Is it possible? No, your index 3 is telling that you can make maximum 2 jumps, but you require 3 jumps to reach at 6 starting from 3. So it is not possible. Now 6 minus 4. Can you reach 6 from 4? No, because you can make maximum 1 jump and you require 2 jumps. So 6 minus 5. Can you reach 6 from 5? Yes, because you require only 1 jump, but it is showing you that you can make 2 jumps. So it is possible. So you see, to reach 5 from 0, you require just 3 jumps, and from 5 to 6, you require 1 more jump. So 3 plus 1 is 4. Now you take the final location, I is equal to 7. And similarly, if you keep on moving from 0, 1, 2, 3, 4, 5, and if you reach at 5, you see 7 minus 5, you require 2 jumps to reach from 5 to 7 directly. And yes, your index 5 is telling you that you can make that jump because it is having value 2. So you can make a direct jump from 5 to 7. So what your 5 is having here? Your 5 is having 3. So you can make a single jump from 5 to 7. So 3 plus 1, 4. That means you require 4 jumps to reach from 0 to 7. That is the optimal solution. So here you see, every time you are making a calculation for a particular index location, with the help of the previous calculations we made and put in the solution array B. That is called dynamic solution. Now we can do this by writing a code in C++. Let's move into the code. Here you see, first we are taking a simple array of size 10, a solution array as we discussed of size 10, and we are accepting how many elements from the user, and we are accepting the elements one by one and populating the array A. And if your array's first location is 0, having value 0, that means you cannot make any jump from the first location, then you cannot find any solution, because if you cannot take a jump at least from the first location from where you are starting, then there is no question of having any solution. Or if the n is 0, obviously, then there is no solution possible. You are returning. Otherwise, you are coming here, and as we discussed, the first location must be 0. The first B0, here you can see it must be 0, because you don't need any jump to take to reach at 0 location. And now you are running a loop from I is equal to 1, and you are going up to the last location. Why from I is equal to 1? Because we need to populate these values starting from 1. That means you are populating the solution array from index 1 and going up to the last value. That means if n is equal to 8, that means you are reaching up to 7. Now you enter, and within this loop, for every index, that means for index 1, 2, 3, you need to check whether you can start from 0 and directly reach at the first at the desired location or not. That means in our example, say arbitrarily, if I want to reach at 4, always we are trying to see that whether it is possible to jump directly from 0 to 4 or not. If it is possible, we will take that as solution. If it is not, we will try it for 1. Otherwise, we will go for 2 this way. So a inner loop is running from j is equal to 0 up to less than I, because you need to reach at I from the previous locations starting from 0. So you will enter into the loop and check that condition. But why this condition? What we check condition we are checking? Here we are checking whether I minus j is less than equals to aj or not. I minus j less than equals to aj or not. If so, then you are entering and simply modifying or populating the value of bi by bj plus 1. Now again come to that condition that you can remember we were checking that condition. Is it possible, for example, say, is it possible to reach at 4 starting from 0? So how many jumps you require? 4 minus 0 is equal to 4. Is it there at that location? See, if I is equal to 4 and j is equal to 0, you are checking whether I minus j is less than equals to the value present at aj or not. If it is less than the value present at aj, then okay, you can make a jump. Then what you are doing? You are simply adding the content of aj with 1 and putting into the solution array. That means at bi for 4. I am taking that example. Say we want to reach at 4 starting from 1, because it is not possible. You can see it is not possible to start from 0, because 0 is having 2 and you can make only 2 jumps. So you cannot reach 4 directly from 0. But if you consider I is equal to 1 and I is equal to 4 and j is equal to 1, can we reach I from j? Can we reach 4 from 1? So how many jumps you require? 4 minus 1, that is 3. So how many jump? I is equal to 4 and j is equal to 1. So if I minus j is less than equals to the value present at aj, if so, yes, it is so, you can make 3 jumps and you require 3 jumps to reach I from j. Then what you are doing? You need to see what is the value present at bj. J is here. At bj, what is the value? you just add 1 with that. You just add 1 with that to get the value at 4. So plus 1 gives you 2. So you enter and you populate the value of bi by adding 1 with the value at bj. That will give the value of bi, which is the minimum possible jumps you require to reach at 4 from j is equal to 1. So see, bi is equal to bj plus 1 is our step. And once you do this, you simply break, because you got your solution. By moving further, by taking your j further, will not give you any minimum solution, because more and more you reach near I, you definitely require more number of jumps, or maybe equal. It cannot be less. So keep on doing this until you reach at the last location. That means I becomes n, you stop and come out. One test case, that is, see this one, it is giving location 0, 2 jumps possible, 1 jump possible, and 0, 0, 0, that is given. So apply the technique. First, obviously it is 0 initialized. Then to reach at 1 from 0, you require 1 jump. Yes, it is possible. It is having 2 jumps. So from here, you can have just 1 jump. 0 plus 1 is 1. To reach at 2 from 0, you require 2 jumps. Yes, still it is possible, because you have 2 jumps here you can make. So from 0 to 2, you can just add 1 to get 0 plus 1 is equal to 1. By making 1 jump, you can reach from 0 to 2. To reach at 3 from 0, is it possible? You require 3 jumps, but it is giving you only 2 jumps possible. So not possible starting from 0. So is it possible from starting from 1 index, from index I is equal to 1, you require 2 jumps? No, it is not possible, because you can make maximum 1 jump. So is it possible to start from 2, index 2, to reach at I is equal to 3? You require only 1 jump to reach 3 from 2, but you can make only 0 jump. That means you cannot reach from 2 to 3. So no way it is possible to reach at 3. No way starting from 0. So this problem doesn't give you any solution. So this case has to be considered. So when it is, we can understand that it is not possible. You are starting j from 0 and going up to less than I. For 0, it is not possible. For 1, it is not possible. For 2, it is not possible. So when j, you are incrementing j and it reaches I, the inner loops condition is violated. And you can understand that it is not possible to reach I from any previous location. So you can easily understand. So if that is the thing, if I equals to j when you are coming out from the inner loop, then there is no solution possible. So you need to add this in your code. Here, once you come out from the for loop, you just check that condition. You just check that condition. If I equals to j, that means the inner loop runs forever and reaches I. Then there is no question of having any solution. So this is to be included also. You take that and no solution possible and return from here. There is no question of printing any solution. So this is the code. Let's run it and see whether it is running fine or not. We will take the examples we have discussed. Say enter number of elements. I am taking that where no solution is possible, that example. Say we are giving 2 1 0 0 0. See, no solution is possible. Again you run, and while you are running, you take the conditions we discussed. Say this one 23022, or this one where we are getting the answer as 4. How many elements are there? 8 elements are there. 231 21202. So run it. 8 2 3 1 2. Let's see again. 21202. 21202, and it is giving you the solution as the last one. I am printing all the values here in the last loop, and it is giving you that minimum of number of jumps you require to take to reach at the last location starting from the first location. That is the answer. It is giving you that 4, the last value. You see, I have printed all the values just for your convenience. You just make a pause of the video and see what the code is telling you and run it on by own. The last value, I told you that in dynamic solution, in dynamic technique, the last value of the array, the solution array, is the answer. Here we are starting from k is equal to 0 and going up to k less than n, and k minus 1 is giving you the last, the answer, desired answer. So that is all about the solution of this problem. I will come up with more exciting problems and their solutions for coding round. Please subscribe my channel and like it and share it if possible. Thank you.